anyway, you know what? If you are applying these kind of formulas and you make a mistake, I don't have any mercy. Again, let me tell you this. Those of you who are using fancy formulas, fancy methods, they are seemingly more complicated. The chance of you making a mistake goes 10 times higher. Is that clear? If you apply these kind of more general methods, more fancier methods, more advanced methods, and you make a mistake on any part of this, that could be 10 points off immediately, because the problem was not meant to be solved this way. It was meant to be just solved like this. And if you solve like this, there's not much place, not much room for making a mistake. Whereas if you use this here, now the chance of you making the mistake is much, much higher, and you are spending much more time as well. Ow. So once again, in this class, you know what? I like to use very simple ingredients. You know what? I like to use simple ingredients to create interesting questions. So I'm not going to ask you to memorize like the area code or things like that, which nobody knows. Well, area trapezoid you have to know, like I don't know, some maybe a volume of a frustum. I don't know what frustum is. Well, if you don't know, it doesn't matter at this time. But anyway, fancy methods is a negative to me. Fancy methods, no, negative. That's not a good sign. Okay, the method might look very fancy to you, but the solution is better, is superior if the method is more primitive. Is that clear? It's more primitive. So that's the better way, and it's also less risky. It's much safer. Okay, so these are the topics mentioned right here, and today I am going to talk about some of the files. I'm going to talk about circles and some basics. And by the way, when you look at all these topics, now these are important topics. It means that tomorrow's test will include all of these topics here. They're the important ones, but it may include other topics not mentioned in class. And of course, all those topics are also from pre-calculus or algebra or basic geometry. Okay? So I cannot list all the topics here. I cannot list all the topics because this is calculus, and pre-calculus and algebra and geometry are required for this course. So cannot include all the topics, but I can say that these are almost all the topics. So don't get mad at me if you have something which is not new. And there could be some word problems as well, or systems of equations. Again, there are a lot of repetitions here, so I don't know. But anyway, these topics, they're like the bulk, okay? And of course, when I say square roots, did I say square roots? Yeah, simplifying, rationalizing, and then where did I put here? Radicals? Yeah, I think I should say here, radicals here, rationalizing square roots, things like that. Okay, so let me add this here. Okay. So there are a lot of topics out there, and then let's say if you look at geometry, basic geometry, circles and triangles and so on. But I can also give you a hexagon like this, a regular hex. So let me just save this. I've now took a screenshot and then clear this. So I can also give you like a hex. So what is this? So let me that's here, and then I can give you this figure here. Okay, so this I'm trying to draw. Yeah, this is a manual. I should have drawn with the line segments here, but anyway, like this, and this is called a regular hex. Red hexagon. In polygon, regular means what? Regular means
all the sides and all the angles are equal.
That's right. Equilateral and equiangular. Because a polygon can be equilateral. A polygon can be equilateral but not equiangular. or the polygon can be equiangular but not equilateral. Now for triangle, we just say equilateral triangle, because for triangle, if the triangle is equilateral, then it is also equiangular. But starting from four sides, from quadrilateral, equiangular is not equilateral. So for quadrilateral, let's see, for quadrilateral, what is a quadrilateral? It's a four-sided polygon. Okay, in case you did not know, I'm sure that you know all of them. Well, for quadrilateral, what is a rectangle? Rectangle is equal to a equiangular quadrilateral. Quadrilateral. That means rectangle is a polygon with four sides where all the angles are the same. And namely, they're 90 degrees, of course, as we know. And then there's another guy called a rhombus. It's a kind of a bus. What kind of bus? It's called a rhombus. What is that? That's the equilateral quadrilateral. What is a square? Square is the equilateral, lateral, equiangular, quadrilateral. That's the full name. Quadrilateral. Anyway, I just make it. I try to make it a little bit complete here, but anyway, so you have to know these things. So I said basic geometry, and of course on the test I can give you a hexagon, or I can give you a dodecagon. I will give you an octagon or dodecagon. What is a decagon? Decagon, 10 sides. You know what? Decagon is a poly with how many sides? 10 sides, dec, and 10 sides. And then sometimes I give you a dodecagon. Dodecagon is equal to poly with what? A polygon. By the way, poly means polygon in this case, not polynomial. So maybe I should write polygon. So you may not know that poly means many things, right? But polygons in this case, polygon. Polygon with what? With what? 12 sides. Okay? So these things, an octagon is 8 sides. Yeah, so I'm not going to mention the septagon, hexagon, nonagon. Of course, I can give anything here, okay? So, and then I give you circles. So today I'm going to spend some time on circles. Okay, so, all right. So any questions here? So anyway, all of these things which I mentioned here, like circles circles and triangles, and especially those two special triangles, rectangles, all of these, you have to know everything. Well, there's not much to know, but it's, the test will include everything. So again, I can give you anything on anything like this. Don't worry, on the test, if I mention dodecagon, I will tell you that dodecagon is a polygon with 12 sides, okay? So don't worry about those terms. I'm not going to give you terms, and especially if you do not know the terms. If I use a term which is not that common, I will tell you what it is, okay? So I'm not tricky here. I do want everybody to at least understand what the question is. So, tricking you by asking for tricking you by mentioning a unusual term, that's not my style, okay? I will tell you exactly what those mean, okay? So terms, you don't have to know this. I will tell you. Like dodecagon, 12 sides, I will tell you, so don't worry about it. If I give you a polygon with 20 sides, then I will tell you that it's 20 sides, okay? I think there's a name for that. What is 20 sides? I kind of forgot. What was that? Anyway. So don't worry about it.
Isohedron?
What is it?
I think it's
isohedron?
Isohe.
Oh, yeah. Iso something. You're right. But you know what? Don't worry about it. Okay. Some of these terms I don't even know. But anyway, when I use terms which you don't know too well, then in most cases I will define them. I will let you know what they are. Of course, you do need to know what equilateral and equiangular mean. They're very, very basic. Equiangular means same sides. So now let's look at the picture here. Look at this picture. rectangle is like this. And rectangle, as you can see, we have this, right? All and wait a minute, are you asking? Is somebody trying to ask me a question? Hello?
Sorry, my mic was unmuted.
Okay, all right. All right, you know what? How about this? Let me mute everybody here. But all of you are free to unmute yourself and speak to me, okay? I just don't want to hear any of your background sound here. Okay, so let me just allow them to unmute themselves.
You muted yourself, Professor.
Okay, there you go. Yes, I think I muted myself too. So yeah, okay. I guess when I say mute all, I guess that includes me. Okay, all right, that's okay. All right, so there we go. And so that's the rectangle. So what is a rhombus? Rhombus is like this. Rhombus is shaped like this, also known as a diamond. Diamond is basically a rhombus. Diamond is a common term, and so that's a rhombus. Rhombus is a quadrilateral where the sides are the same, but the angles have no condition. So if four sides are the same length, then that is called a rhombus. Of course, square is a special rhombus. The square is a special rhombus. Square is a special rhombus, which is also a rectangle. That's what we call a square. The square, the official name would be this right here. This long name is actually the official name for the square. Now for triangle, we just call it equilateral triangle. We don't call it the regular triangle, because for triangle, equilateral triangle implies equiangular triangle. So for triangle, if it's equilateral, it is also equiangular. Okay. So anyway, all kinds of formulas apply there too. But anyway, I'm not going to mention all those basic formulas and theorems. Okay, so I'm going to assume that. So now what I'm going to do is I'm now going to clear this, and now what I would like to cover some more topics on M0 test prep. But before I get there, I would like to go over this file right here. Let me see, which I added, which I actually brought up to the top, and that is let me see. Oh wait a minute. The file I'm going to open is this. I'm going to spend some time on circles. So what is the file name? The file is this right here. Yeah, it's named 0221. So there are actually quite a few 0221s here. This is 0221 is actually pre-calculus, chapter 2, verse 1 in our official pre-calculus textbook at SMC. But let me open up this.
Excuse me, Professor. Is anyone not getting the video feed from the professor?
Yeah, I'm not getting the screen. I don't see your screen.
Okay, so let me see. Let me get the screen. So maybe I'm not sharing the screen here. Okay, let me get the screen. Share the screen, and you are right. I didn't share the screen. So now I suppose everybody can see the screen, right?
Yeah, now
Yes.
I can see.
Okay, so again, the file name is 0221. Like I said, at this point in time, study all the files starting with a file name 02, 00, and 02, and M02. All right? So I think I said that already many times. So this is one of those files starting with 02. Means that it is actually part of either pre-calculus or algebra. Actually, this is kind of algebra and a little bit of geometry. So algebra and geometry mixed here. This is actually chapter 2 of pre-calculus. This is really not officially pre-calculus. It's actually more intermediate algebra and circles. So anyway, but the circles are a little bit more analytic circles, a combination of algebra and geometry. Okay, and okay, so now let's look at this. In section 2.1, the topic is rectangle coordinates, but I'm not going to talk about the rectangle coordinate system and the polar coordinate system. Anyway, you know what? There's some other stuff here, but the topics which I'm interested in are the ones in the bottom here. And so if you look at in the bottom here and in the middle, we see a theorem. This is actually the distance formula here and the midpoint formula. Actually, on quiz 1, you already had a problem midterm, and so a midpoint, so it's all there. So I'm not going to mention I'm not going to do that. So then example 8, we have distance and midpoint, all of that. And then example 9, perpendicular. Oh yeah, we had that, quiz 1 already. And then example 10. Yeah, now example 10, you can do that on your own. It's a circle problem. Now, I would like to focus on 2 problems, and namely, they are example 11 and example 12. They are a little bit more interesting, little bit more spicy than example 10. Again, so I like to give you problems with a little bit more spicy, so such as example 11. Okay, so let's look at example 11. Now, example 11, sometimes I call these locus problems. Locus problems are problems of this type. So let's say about this, what is this here? Annotate, and then, yes, we have this right here. So it says here, if you look at this, what is the problem here? Find all points. Find all points, and then such that, and then blah, blah, blah. Find some of a So when you have to find all the points with some kind of criteria, that's what we usually call a locus problem. Again, locus problem is a very important type of problem. Let me write down over here. Locus problem. Locus problem, what is a locus problem? The locus problem is basically this. Find all points such that, then blah, blah, blah. It's just we have some criteria. And one of those conditions we have there, this is what I call the criteria. So let me write over here, let me circle in this and some kind of condition. A criteria is basically some kind of a condition which satisfies or property or something. So find all problems such that, blah, blah, blah. And this type of problem is actually very common, and you are going to see this type of problem a lot. You have already seen these kind of problems in your pre-calculus class and your intermediate algebra class, but it is, generally it's a general type of problem. So now let's look at example 11. Let A be the point 0, 2 and B be 6, 0. Find all points P on the line y equals 4 such that AP is perpendicular to BP. So that sign right there between AP and BP means perpendicular. Okay, so let's first try to understand what the question means. Again, in all math problems, the first step is for you to understand what these problems mean. Okay, so let me now draw this here. So let me now try to figure out what the question means. So what we have is, okay, so I think we need a XY plane here, XY coordinate system. And then like this is X, and that's Y. And then what do we have here? We have a point here called 0, 2. So 1, 2. So I can mark this point 2. So I can just mark the number 2 here, but that point is actually 0, 2, and let me mark that as point A. So the point A is 0, 2. And then now the point B is, let's say, it's 4 here, and then 6 is over here somewhere. So this is now 1, 2, 3, 4, 5, 6, and this guy is 6. So the point is really 6, 0. On the XY chart, on the XY plane, I can just write 6 there, but that point is really 6, 0. Because it is a point. Okay? So it's at 6, 0. And then now the question is, now what is the question? Let's understand the question. Find all points. And by the way, many times I am not going to say all points. I will just ask you to find points. Find points. Now in math, I just want to let you know. In math, when I say find equations, when I say find what? Find a solution. Find a solution basically means find all solutions. Okay, so this is a This is the general way of this is the general way to understand these questions in math. Also, when I say find points, means find what? Find all points. It's assumed. So when I ask you to find 4 points, then don't just find 1 point and then tell me that's the solution. Okay? You have to find all the points. And you have to show, and must show, that they are all the points. So you don't just find all the points, but you have to show that they are all the points. Or if you find one number, then you have to show that that is the only number. Okay? You cannot just say, so you have to actually derive the solution. So sometimes I use that word. You have to derive the solution, not just guess the solution. If you guess it, then you don't know whether that's all of them. So you have to show that your solution is complete. It's like this. If I tell you that, let's say, give an example. You know what? There's a side example again. Let's say take example. Let's say x squared. Let's say solve x squared is equal to 2x. Let's say if I give you a problem like this, and then let's say I put a square here, then what is the solution to this guy? Solve x squared equals 2x. Well, what is the solution? Solution x equals 0? Is that a solution? How about this? Solution? And then what? Solution x equals 0? Yeah, that is the solution, yeah. X equals 0 is the solution. 0 squared is 2 times 0, so that is the solution. But if you write x equals 0 here, that is not a complete solution, because first of all, we don't know whether that's the only solution. Is that all the solution? We don't know. In this case, we have 2 solutions. And so you have to show, the work has to show that that is all the solution. Okay, it's so much on that. But what I'm saying is, you have to always make it complete. Okay, so that's it. Now let's come back to this question here. Okay, now what is the question? Now we have A and B. Now find all points P on the line x equals 4. On the line x equals 4. So it looks like we have a line here. The line is now x equals 4. So this line is what? This line is x. This line is y equals 4. Sorry, y equals 4, not x equals 4. Y equals 4. And now our job is to find the points P, or all points P on the line y equals 4. That means the point could be, the point could be here, or here. We don't know. Don't know. And these are what I call point P. P, where is it here? And then now we have to find all points P such that the segment AP, and the segment BP, which is this one right here. Oh, this guy's B, by the way. I didn't write that down, did I? So that one is actually B, 6, 0. And by the way, don't confuse between 6, 0 and 0, 6. Okay, that those are high penalties. Don't tell me, make sure that you know what, when you have any kind of question here, make sure that all your points are correct. Don't miss copy. My general recommendation is to read the question at least 3 times. Make sure that you do not misunderstand the problem and they use the wrong point. So that, so that this is a right angle. So we have 2 lines here, and now what? Now we're going to find the points, all the points P such that AP and BP are perpendicular. So now in this case, we don't know how many points there will be. Do you think there will be one such point P? That we don't know. We don't know whether the 1, or maybe there might be 2, or could there be 5 such points? We don't know. But that is something you have to figure out. Okay. So the question is, how do you do this? So everybody understand? Does everybody understand the problem now here? Does everybody understand example 11? Does everybody understand the problem? Yes?
Yes.
Or no? Okay, so now this is example 11 now. So what I'm going to do now is I'm going to save this and then clear this. So what I'm going to do now is this. I'm going to open another file here, which is the next one is actually 0221, and then I said example F21, example 11. The very next file is actually the solution to this example 11, which I just explained to you. So let me just open up this guy. That's exactly this one right here. So, so now let's look at the solution. Example 11. That's the one which I just explained. Okay, so here's A and B, and now there's a line y equals 4, and the point P is over there. Okay, now generally, when you have a problem involving, so I actually write down right here. So what is this here? So here I wrote down right here. So here. So I'm looking at this guy right here. So problems involving perpendicular lines. Whenever you have a problem involving perpendicular lines, usually there are two methods. Again, whenever there are problems involving perpendicular lines, usually there are two methods. And the two methods are the first method by slope. That's the first method. And second method is by applying the Pythagorean theorem. Now in this class, this is Calculus 1, so I don't know how many of you know how to prove the Pythagorean theorem, but obviously I cannot go over everything. In my pre-calculus class, many times I do prove the Pythagorean theorem, but not always. But anyway, you know what? I think if you're a calculus student, I think it's probably not a bad idea for you to learn the proof of the Pythagorean theorem. There are many ways, so many proofs of Pythagorean theorem. The most well-known proof of Pythagorean theorem is the Pythagorean theorem proven by Euclid. Euclid is a later mathematician than Pythagoras, and therefore, so he's one of the top mathematicians in history. And and then anyway, you can find that. Okay, so if I have time here, but I don't have time, that will cost me about 15 minutes. But you can look it up. But again, if you are, I think many formulas we have been memorizing so far. But if you're taking calculus, I think it is now time that you know how things are proved. Okay, all right. Okay, so let's come back here. So this solution here is now the solution by slope. On this page is the method by slope, and this is actually the most standard proof. This is the most common standard way of solving the problem. But Pythagorean theorem works well too. It's actually very good too. So when you have a problem like this, then I do recommend you to do both ways. So for this problem, why don't you try to solve the problem by Pythagorean theorem? Okay, I can let you do that on your own. So let's do that. Okay, so now what I'm going to do is by slope. So let's look at it. So now find all points P on this, and then A, P, and B are perpendicular. Okay, so now how do you do that? So A is this. So here, now let me, it's kind of messy here already. So let me write here. Okay, so now here, this is where the solution begins. A is 0, 2, and B is 6, 0. And the point P is a point on the line y equals 4. So we can say that this point right here, we don't know what the x coordinate is. So why don't we call this point A? By the way, do not use x. Here, when we name this unknown point P, do not name the x coordinate x, because x is already used up here. Now, sometimes it is okay to use the variable x here, but that x has to be consistent with this x. And if you are not being careful, this x and that x will have a problem. If you're not sure whether you can do that or not, then please use a different letter. In this case, we'll call it A. In fact, this A is a parameter because this is an a number which is unknown, but this number is fixed. It is not changing. It is not changing once the problem begins. So A is not a variable. A is actually what we call a parameter. A parameter and a variable, they're not the same. Or maybe some of you may not know exactly the difference here, but a parameter is an unknown constant. It is a constant, it is unknown, but as the problem begins, it does not change. The value does not change. So we don't know what the value is, but the value does not change within the problem. Whereas a variable is a letter which represents a quantity which changes even throughout the problem. Okay, so anyway, we will call this point P A, and then the y coordinate must be 4, because the condition is that this point is on the line y plus 4. So therefore, P, I'm going to call this guy A, 4. And now, what do we do? Well, we want this guy right here. We want AP and BP to be perpendicular. Because of this red mark right here, it's kind of messy. We cannot see this here, but anyway, this is perpendicular. AP and BP must be perpendicular. And now here, I'm trying to use the slope method. So what do we do? So let's now AP. So here, we want to apply this method. We want, this is, I said, we want this. What do we want? We want the slope of AP and the slope of BP to be -1. And this I already mentioned before. The product of two slopes must be -1. Of course, this condition exists here when both are not vertical. When both are not vertical. So what happens if they are vertical? Then what happens then? If they are vertical, then we cannot apply this theorem. This theorem right here, slope times slope, the product of two slopes is -1. This formula applies when either of the slope, when both lines are not vertical. Okay? If one of them is a vertical line, then we cannot apply this. You have to remember the horizontal line and the vertical line, even though the product is not -1, see this vertical line here and the horizontal line, are the two lines perpendicular? Yes, they are. Are the product of the two slopes equal to 0? No. This one, the slope is 0, but this one, the slope is undefined. So the slope is undefined and slope is 0 here. Product is not -1. But these two lines are still perpendicular. So again, for non-vertical lines, that's the case. So now let's look at the case. Okay. So what is the slope of AP? The slope of AP is this guy right here. 4 minus 2 over A minus 0. That's the slope of AP. Now what is the slope of BP? Oops, what is this? Sorry. What am I doing here? All these junk mails. I'm getting all these junk bits. Okay, there you go. Okay, so and then a BP, the slope of BP is this guy right here, 4 minus 0 over A minus 6. That's what we get right there. Does everybody see? Okay, any questions up to this point? Is everybody following me here? Does everybody get up to this point right here? Up to this?
Yes.
Yeah. Now note that this equation will be applied when A is not 0 and A is not 6. This is very important. So now, when A is 6 and A is 0, what does that mean? A is 0 and A is not 6 and A is not 0. Now, what happens when A is 0? When A is 0, then this thing becomes undefined. But now let's see, when A is 0, what's the point? When A is 0, it's actually this point right here. You know this point right here? This is the point we get when A is 0. This is the point 0, 4. The point is 0, 4. And then now this point right here is 6, 0. This is the point 6, 4. That's when A is equal to 6. So A is equal to 6. When A is equal to 6, the point in question is 6, 4. So the solution, what I'm doing right now, will consider all the points except those 2 points. The points 0, 4 and the points 6, 4 are excluded on the solution. So at the end, I'm going to make some comments about those 2 points. Okay. So now what you do is, now we are going to solve this equation here. when you solve this equation, now we are right here, and then you multiply both sides by 8 times a minus 6, and if you do that, you get this equation right here. And then what? You solve that equation, and then you multiply all that, and then organize that equation and solve by factoring. It's factorable, and then we get a is equal to 4 or a is equal to 2. Okay, good. So when a is equal to 2 and a equals 4, and both are not 0 nor 6, so the 2 points are solutions. So we now get 2 solutions, 4, 4, and 2, 4. So we have found 2 points which satisfies these conditions. So we have found 2 points. 2 points on the line y equals 4, which has this property, where AP and BP are perpendicular. So 4, 4, and 2, 4 are solutions. Now done. And now what we have to do is now this. Consider the other cases. What happens if a is equal to 0? So now I wrote down case a equal to 0. Case a equal to 0. When a is equal to 0, that means the point is over here. When a is equal to 0, the point is right here. Now in this case, the point is right here. In this case, is AP and BP vertical? If that's the point right there, let me mark a big point right here. That point is 0, 4. The A is here and B is here. Now, if that's the point P right there, is 0, 4, is AP and BP perpendicular? Note that AP is this, and BP is that. Is AP and BP perpendicular? No. We know that is not perpendicular. How do you know that is not perpendicular? Because AP is a vertical line. But BP is not horizontal. See? So that's what I wrote down. AP is vertical, but B is not horizontal. And therefore, the 2 lines are what? They're not perpendicular. So 0, 4 is not a solution. Everybody get this? When the point is 0, 4, and a point on the line y equals 4, the question is AP equal to BP? Is AP and BP perpendicular? No. Now the thing is, the reason why you have to check this separately is because this, the product of the 2 slopes is equal to -1. That theorem does not apply here. So the slope times the product of the 2 slopes is -1. That theorem does not apply. Why? Because the line AP is a vertical line, and a vertical line does not have a slope. So when you get into a problem which involves a vertical line, the slope argument does not apply, but it could still be a solution. So you have to check it out. In this case, what is it? It is not a solution. Now what happens? Okay, so that's not a solution. So now let me go back here. Now what happens if the point is? What happens when a is equal to 6? When a is equal to 6, that means the point is when a is equal to 6, then the point is 6, 4 right here. Is right here. Now in this case, is AP and BP perpendicular? BP is this guy, and AP is this guy. Are the 2 lines perpendicular? What do you think?
No.
They're not. In this case, therefore, AP and BP are not perpendicular. Therefore, 6, 4 is also not a solution. So they're not a solution. But the important thing is, not for this problem, but for other problems, these exceptional cases, we might get a solution on one of these exceptional cases. That's why you have to be careful. So you know what? Maybe I'll should I mention that case? Yeah, let me mention that case. So you know what? One of the problem I have is this guy right here. And so let me do this. Let me save this, and then I'm going to clear all this. And then I'm going to, how about this? I'm going to go to the whiteboard. And now this time, I can actually give you a problem like this. But this one, I'm not going to do this, okay? So in this case here, how about this? So example, find all points P on the line y equals x, such that AP is perpendicular to BP. All right, in this case, looks like I didn't tell you what A and B are. And so let me write the AP and BP right here. So how about if I let A be the point? How about let A be the point, what is it, 0, 1? 0, 1. B be the point, B be the point what? How about, let me see. Well, you know what is a good number here? How about 3, 0? If I give you a point like this, you know what? Let me just do this quickly. This is very similar. Now we have this. Then we have this. Now we have this. Then, what is it? Zero, 1 is over here. And the B is over here. 1, 2, 3. So as the line goes like this. So now the point P is on this line right here. This is A and this is B. So this here, oops, AP and BP. This is B. Oh, you know what? Let me use a red marker here. So let me change it to red. And the AP is this guy. EP is this guy. So in this case, we can let this X, in this case, what is P? In this case, P, why don't we let the X coordinate be A, since we don't know? And in this case, since this point P is on the line Y equals X, that means Y should also be A as well. Not 4, but A in this case. Because the point should be on the line Y equals X. So the X coordinate, you just call it A or B or whatever. Any letter which is not used, and then the Y value must, follow the condition. It says here Y equals X, so A. And then now you can apply the same theorem. So you can apply this. You can say slope of what? Slope of what? AB. AB times the slope of BP equal to -1. Right? But however, this one here, when A is not 0, and A is not, you know what? Maybe I'll just write this. Maybe I'll just write this here. A is not 0, and A is not 6. Then I'm going to fill this in, okay? Because I don't have an unequal sign here. Yeah. A regular keyboard does not have an unequal sign, so let me just write this. When A is not 6, and A is not 6 and not 0. When you get the slope of A and when you get the slope of AP, of course, that assumes that A should not be 0, because if you do that, so anyway, you get this. Now, when you get this, then and then you can see that this equation right here, and then you will have this times that equals -1. And when you look at this equation, you will see that A cannot be a 6 or 0. You can see that. And so now, blah, 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 and then you might get a solution, and then you get a solution here. And then at the end, we now have to consider these two cases here. How about when A is 0? How about the case when A is equal to 0? And then on here on this side, we have another case. Case when what? A is equal to 6. Oh, sorry, not A is equal to 3. Oh, it is a 3? Sorry. It is not 6. It's actually 3 in this case. My mistake. So therefore, I should say not 6. It should be 3. not 3. Okay? Because when A is equal to 3, then one of the lines, namely the line BP, is a vertical line. And then therefore there will be no slope. When A is 0, then AP will be a vertical line, and therefore there will be no slope. So again, whenever you use slope, whenever you have something with slope, then vertical lines cannot be applied. So those theorems cannot be applied to any vertical lines. Okay? So vertical lines are good lines too. They are lines just like any other line, but somehow the concept of slope are bypassing the vertical lines. But that's a sad thing. Okay, but anyway, somehow they don't have a slope. The slope argument does not apply to vertical lines. So what happens in this case? What happens when A is equal to 0? When A is equal to 0, do we get an answer? If A is equal to 0, then what that means is the point P is actually what? The point 0, 0. Is AP perpendicular to BP? What do you think? Is AP perpendicular to BP if P is 0, 0? What do you think?
Yes.
Yes, it is. In this case, we do get a solution here.
Hi, baby.
And then now, how about if you look at the case when A is equal to 3? When A is equal to 3, what is the point? The point P is going to be now 3, 3. In this case, the question is AP perpendicular to BP? Is it? Yes or no?
Yes.
AP perpendicular to BP? No, not in this case. So the answer to this guy is no. So in this case, what happens is you will get a solution over here at the very top, the first part, and then you now get another solution, which is 0, 0. So you can get a solution under these exceptional cases. So you have to be very, very careful. Again, you have to remember, slope, then the vertical lines have to be dealt separately. But vertical line is actually a very easy line. So again, vertical lines are very easy lines. So you have to know everything about vertical lines and horizontal lines. And again, these lines are easy. They're not hard. So even though we cannot apply the theorem, it's actually quite easy. Vertical lines are and horizontal lines are very easy to deal with. So therefore, but the argument has to be applied separately. That's what I'm trying to stress. All right? Anyway, I'm going to let you do the rest of it. So that's it. And so now I'm going to now go back here. And now what I'm going to do is I'm now going to now share the other file. Where's the other file? What I'm going to do is files here. Yeah, files. Yeah, I'm going to go back. And now let me do this. I want to show you the page. Sharing, let me share this. So now what I like to go back is section 2.1 again. I'm going to go back to that same old thing, same old file. Now what I like to do is spend a little bit of time over here. Oops, what happens? File is not coming up. Okay, let me wait. Yeah, there we go. Section 2.0 is back again. Okay, so now here and now, so that was example 11. Now let's look at example 12. So maybe example 12, you know what? Maybe I will let you do this on your own. Example 12 is also a problem in circles. Okay. Okay, so let's do this. Now, example 12, there are many ways to do this. Example 12 has many ways. If you do this correctly, in the correct way, it might only take a minute or two. But if you do this the long way, it might take 20 minutes. Or it might be so messy you will not be able to get the answer. So first, let's try to understand what this problem means. Okay, example 12. Find the equation of a circle which passes through the point 0, 2, 0, and negative 4, 0. So let me explain that. First step is to understand what the problem is. That is always the question. So let's do that. And let me see. Negative 4, 0. Let's see how should I? Yes, so it looks like we do have a lot of points on this side. Oh, you know what? This is too thick. So let me just use a regular thickness here. And okay, let's do that. Let me do this again. Let me start from here. Then let me do. Okay, good. Okay, so now let's see. Where are the points? The points are 0, 2 is over here somewhere. 2. I'll just write 2 there. Means 0, 2. Next point is 2, 0. So next point is over here 2. Right here. And then now where's the other point? The other point is negative 4, 0 is here. So this is negative 2 and negative 4. It's going to be somewhere here, negative 4. So let me put it negative 4 here, and the point is over here. Okay, so looks like this is the x-axis and that's the y-axis, and we have 3 points, namely 0, 2 and 2, 0 and negative 4, 0. So now what is the question? The question is to find the equation of a circle, which passes through these 3 points. So how do you get that? How do you find the equation of a circle which passes through these 3 points here? Do you find it? Now, what is the midpoint of this point 2, 0 and negative 4, 0? This point right here, negative 4, 0 and 2, 0. What is the midpoint of this? The midpoint is, of course, over here, negative 1, 0. Do you think that is the center of the circle? What do you think? Is that the center?
No.
No. As you can see, this is not the center because this C is 3 away from this point, from negative 4, 0. It is also 3 away from 2, 0. But if you try to find the distance of this guy, this is not 3. In fact, this one is a square root of 5. 1 and 2, so it's square root of 5. So that C is not a circle. This is not the center. So let me just go back and undo this. So how to get the center? How to get the now? In order to find the circle, all of you know enough about the circle. Basically, we have to find 2 things. Must find the center. Must find center and radius. And then once you get the center and the radius, then you can write the equation of the circle. Okay. But anyway, maybe I'll let you do this, all right? Now, what is it that you need in order to do this problem? Again, there are many ways to do this. Again, if you do it the correct way, it should take about 2 minutes. If you do it the wrong way, it might take about 20 minutes. Or you might never get the answer because the calculus is so messy. Okay, so there's a big difference here. In this class, I'm constantly stressing the method is very important. So what is it that you know? What is it that you have to know on this problem? What is that you have to know? Well, you know what? Maybe I will let you do this on your own. Okay? So why don't you try this? Try this. Okay, why don't you try this problem? Okay. By the way, you want the answers? Answers answer will be found. And answer found on the next file. Okay. Name example okay. There's a file right after this file. And then it's not right after, but I think it's exactly, we will have example. Okay, so anyway, let me save this and then clear all this. And so what I'm going to do is I'm going to now show you what that is. So if you if I go back here, slow. Okay, let me go back here. Stop closing. Oops. What's happening here? There we go. Section 2.1. Let me close this. Oops. I'm trying to close this here. How do I close this file? You know what? Let me just go to files. Oh, you know what? Files? Am I on the files? I'm on the files. Oh, there you go. If you look at this here, yeah, there you go. Example, the file number 0221, and then it says example 12 right there. Okay. So which is a little bit below the file 0.001 0221, and then if you open that one, you will see the answer. But anyway, why don't you study them on your own? I cannot go over everything here, so you study them on your own, okay? So there are a lot of things to study for the test tomorrow. Again, all the things which I mentioned in class, they're all covered, obviously, and also all the topics. And now then what I would like to do is, I would like to go back to factoring. Okay, now I would like to go back to factoring. But before I get to factoring, let me open up a whiteboard here, and then I'm going to explain to you the factoring principles. Okay, so what I'm going to do is, where's the whiteboard? Whiteboard, yes, let me open up the whiteboard. So today what I'm going to do is, I'm going to do the lesson on factoring. Factoring, so let me do this. So let's say number for example 1. Example 1, let's say 2a, and then times, and the what, and the plus, and the how about 6 times a. Then example 2, let me say 2a, and then a plus, and then I'm going to write the exponents, okay? Then after complete problem here, and then a. Then example 3, about 2a and b and c, and then a plus, and then 6 and the a, and then how about the let's say c, and then let's say d. Okay, so I'm going to do this here, and so now let me fill in some numbers. And let's say this guy is, let's say 5. So what happens if this guy is -2 and then -5? Well, you know what? Let me, how about -2? Okay, this is now negative 2. Just 1 second. The space is small here, so let me make it a little bit thinner. -2. This is now a. Then b. Let me put -1 or -3. D. And then we have a is equal to, let's say, how about 7? And then c. Let's make this, let's say, how about 5? And then let's make this guy, how about -4, then d to the negative, let's say, how about -8. Okay, so let's start from example 1. How do you factor this? How about example 1? What do you factor? Well, we have 2 terms here. What is the numerical common factor? That's 2. And then a to the what factor? What do we factor? A to the what power?
Squared.
Yeah, a squared. Well, y squared? Why 2? Because 2 is the lower of 2 and 5. Basically, that's what it is. So that's what you learn, right? 1 and then plus. So therefore, this is going to be 3a cubed. This is not so hard. So we can just do the rest of it like this. And then basically that's the end of that. And now how about if we look at example B, 2. Now, so we have once again 2 terms here. So first we look at numbers. So what is that? So that's 2. So 2 is a numerical common factor. And then now, what is the common factor for a? Well, we have a to the -2 and we have a to the -5. So now this time, what do we factor? A to what power? -2 or -5, or what do we factor here?
-5.
1, which is 4. -5. No exception. And then if we do that, then this now becomes a cube. Now the best thing is for you to guess this guy. So when you have a cube here, then a to -5 times a cube is a to -2. And the plus, and then the other guy, the second term in this case is the numerical factor must be 3, and then a to the -5 is then that's it. So that's how it goes. So that was example 2. Now let's look at example 3. Now, example 3, things are getting a little bit, by the way, let me make some comments why we factor 8 to negative 5. Because if you look at example 2, the expression is really this. It's really 2 over a squared, and then plus 6 over a to the 5. So if we actually write those instead of negative exponents, we write that as rational expressions with positive exponents. That's actually the same as this guy right here. This guy same as this guy right here. This same as this guy.
Oh, look at him.
Now in this case, a squared, a to the 5th power. So what would be the common denominator? The common denominator would actually be this. Would actually be a to the 5th power. And then it's 2. So if it's written in this rational form, rational expression form, then this is what we would actually do. And that is exactly what this is right here. So it's the way we are writing is a little bit different, but it's actually logically consistent. And then once you have that, then this remaining will be a polynomial, and that will be, of course, a to the 5th power, a to the what power? 3rd power, and then plus 3. So if you write it the other way, it is easier to understand. But in math, especially in calculus, in calculus is higher, we use negative exponents. This is the standard way of expressing the exponent rather than this rational expression here. Although I will accept this too. In this class, I will accept either way, but this is the way which is the more official notation. Either way will be acceptable though. Now let's look at example 3. Example 3, once again, we have 1, 2, 3. So we have one term here, and then another term right here. Now here, things are getting a little bit tricky, and as you'll see why. Okay, so we have 2 terms here, so what do we factor? So let's see. Let's look at these 2 terms here. First, let's look at the numbers, 2 and 6. So that means the numerical common factor is 2. Okay, good, done. Times. Now let's look at the a's now. A to the negative 2 and it is a to 7. So what should we factor? A to the what power? A to the what exponent should we factor? Somebody tell me what exponent we have to factor? We have a to the negative 2 and a to the 7. So what should we factor? A to the what power?
Negative 2.
Negative 2, you're right, negative 2. Good. Now, let's now go to the next one. Next one is, we have a b here. We have b here, but note that the second term does not have a b. Should you factor b or not?
No.
Actually, the answer is yes. This is the tricky part. The reason why we have to factor b to the negative 3 is because it's like this. It's like having b to the negative 3, and then let's say 2 this, and then plus, and then 6 times, let's say this is now b to the 0. Note that b to the 0 is actually 1. This guy is actually 1. Anything to the 0 part is 1. Now, when you have b to negative 3 and b to 0, which one is the lower exponent? Negative 3 or 0?
Negative 3.
Which one is the lower exponent? Negative 3. So if you think this as b to b 2 over b cubed, and then we have, let's say, plus 6. If you write it like this in the rational form, what do we do? We actually factor, create a common denominator like this, b cubed. This is what we would actually do. And then we will write 2 plus, so actually we will factor the 2 here. So let me factor the 2 here. And then what we do get is, we get what? We get 1. This is now 1, and then 1, and then plus. We 1 plus, and then 3, and then b cubed. This is what we would do if you write this in a rational form. So anyway, we come back to the original problem, example 3. We have b to negative 3 and no b here. But even though the second has no b, we will factor b to negative 3 because this negative 3 is actually a negative exponent. And between negative 3 and 0, negative 3 is the lower one. So this is a little bit tricky because when you have negative exponents, this kind of thing occurs. When you have positive exponents, you never have this kind of case. But for negative exponents, you have this case. So that the other guy will have no negative exponents. Here, we want no negative exponents. No positive exponents only. So in the big factor, we only want positive exponents. That's why we have to factor all the negative exponents here. So now let's go back. Now let's look at C. Now, class, let's look at C now. We have C to the 5 and C to the minus 4. So what do we factor now? C. We have C to the 5 and C to the minus 4. What do we factor? Times C to the what? C to the, yes, negative 4. Because negative 4 is the lower of negative 4 and 5. So we factor the negative 4. Okay, now times. Now let's look at the last guy, which is D. D as in dog. So we have D to the minus 8. Did I say D to the minus 8 here? You know what? I'm sorry. Let me change the problem, okay? Let me change the problem here. What I really meant was, I'm sorry, but let me change this to, let me make this green. Let me change this to, sorry, I'm changing the number here. Let me change to about 6, okay? I just changed that exponent to 6. So now, let's see. Again, I changed number 6 there. I just changed it. So now we have a 6 there. Now, let's see. What about the D? We have D to the 6 in the second term. Well, there is no D on the first term. Do we factor the D? Should we factor a D here? D, yes or no? Question mark. Yes or no? Did you factor D? And the answer is? No, not in this case. Because it's D to the 6. D to the 6 is actually compared to D to the 0. And 0 is lower. And so we have to factor D to 0. But D to 0 is 1. So we don't factor. So there's a difference between B and D. D, the lower is the D to 0, which is 1. So we don't factor. But B, the letter B, we have to factor B to minus 2 because it's a negative number. So you get this situation where B is factored, but there's no D. Okay? So now when you do that, then now what is the rest of it? The rest of it, now, you know what, let me do this here. Let me erase this part right here. And so I want to make this thing a little bit larger. So now let's do this. Okay, so now what goes in here? Now this one you have to just guess, basically. That's the fastest way. 2 is here, so no, we don't need a number here. And A to minus 3, we have 8 there. And the B to minus 3, we have B to minus 3, we have it there. And then we have C to minus 4. So we only need a C. So it looks like we need C to the 9. And then plus. So C to 9 is that's all we need for the first term here in this big term, big factor. So we have all that, and then that's the first term right there. So when you multiply this out, you get that right there. So we only need a C. Now the second term in this big factor, let's look at the numbers, 6 here and 2 here. So it looks like we need a 3. We need a 3, and now let's look at the A. We have 8 to 7, but we have 8 to the minus 2 here. So it looks like we need 8 to the what? 8 to the 9. So when you multiply the 8, we get 8 to 7. And now next, B. We need B. There's no B here, but we have B to negative 3. So it looks like we do need a B. We need B cubed. So that way, B to minus 3 times B cubed is B to 0, which is 1. So no B. Now C to negative 4, we have C to negative 4 right here. So that's it. And then now D. Oh yeah, we need we need D to 6 power. So this is now the final answer. Make sense? Make sense here? Class, does that make sense?
Yes.
Yes.
Okay. So in this class, if you understand, you say yes. And if you do not understand, what do? You also say yes, right? Is that right?
Right.
It's a rhetorical question, okay? So when I ask a question, your answer should always be yes. Okay. So now let's do another one here. Now example 4. Let's see what we have here. example. Now, this example is now getting close to what we have in the M0 test prep file. So let me write 2a, and then b, and then b. Let me write a here, and then b here, and then b. And then I'm going to add some exponents, and then plus. And then how about just put a minus in this case? How about let me put an a here this time, and then a, and then b, and then maybe d. So now what I'm going to do is I'm going to put some exponents here. Let me put an exponent of, how about 5 over 2 here. And maybe minus a half power here. And then how about if I put 1/3 here? How about if I put, let's say, 1/3 here? And 4/3 here. And then let's say this one, let me just put, let's say, -2. -2 here. Okay, all right, so we have this. So in this case, what do we factor here? What do we factor? So in this case, once again, we have two terms here, 1, 2. So the first step, let's look at the numbers. Let's figure out the numerical common factor. Well, that will be 2. We have 2 and 8, so the common factor is 2. Oh, by the way, when you have a fraction here, that changes also. But anyway, maybe I'll add fractions a little bit later, maybe. Okay, so 2. Okay, so now 2. Now then a here and a there. So it looks like we need to factor a. So a to what power? A to the -½ power. Because -½ is lower than 5 or 2. And the next one, b, yeah, both have b, so we need a b. So b to what power? B to the lower exponent, which is 1/3. Okay, there we go. B to the a to the 1/3 power. Good. And the times. Now c here, no c, but this is c to the 1, so no c. We don't need c. The common factor does not have a c. Now, how about d? Yes. This is d to -2, so we do need to factor d to -2. So d to -2, so this is what we will factor. Once we do that, then now let's get the rest of it. The big factor here, so what is that going to be? 2, yeah, we have a 2, so we have a 2. And then we need to match with a, 8 to 5 or 2, but we have 8 to the -½ So -½ and then plus what number is going to be 8? It will be 5 or 2, or that will be cube, 3. So this will be a cube. So 8 to the -½ times a cube will be 8 to the 5 or 2. Basically, -½ plus 3 is equal to 5 or 2. Everybody, do you know this? Does everybody know that the -½ plus 3 is equal to 5 or 2?
Yes.
Do you know this, class?
Yes.
Yes. Okay. Now, when you multiply these exponential forms, you add the exponents. So there's a cube. So you know what? Well, you'll get used to it. There are a lot of ways for figuring out what this is. You know, the best way is just do a little bit. Just do a few of these kind of problems here, and you'll get used to it. It's not that bad, okay? But I can tell you how to really get this more officially without guessing. But if you don't guess, the method is going much longer. Okay? I mean, one way is to do this. One way is to do this is 8 to the -½ power, 8 to the -½ power, and then times x is equal to what? Is equal to 8 to the 5 over 2. Oh, wait a minute. What? This is not working. 8 to the 5 or 2. You can figure, and then you have this equation. So we are only looking at the a. So now what do we do? From here, we multiply both sides by 8 to the ½ power. So multiply both sides 8 to the ½ power. So we get 8 to the ½ power, 8 to the ½ power, and then times x, and then times 8 to the, you know what, the writing is not clear. This is 8 to the -½ here, and then multiply this by 8 to the ½ power. Oops. 8 to the ½ power. This is equal to 8 to the 5 over 2, and then 8 to the 5 over 2, and then takes 8, and then times 8 to the ½ power. And then when you simplify this, what do you get? You get x is equal to x equal to what? A cubed. I mean, you can do this, but you know what? This is too long. I mean, when you do these kind of things, you can just guess. Okay, there are a lot of ways. I mean, besides this, there's some other ways too. But anyway, you know what? Yeah. Okay. Anyway, a cubed. And now how about the b? We have b to 1/3. We have b to 1/3, so we don't need a b here. And the d, c. We need a c, but there's no c here. So there's no c. So it looks like we do need a c. And then now the next one, d. There's no d to 0, but we have d to -2. So it looks like we do need d squared. And then minus, because you have minus here. So the first term is now done. The first term of this big factor is now done. A cubed c d squared, and then minus. Now, what's the second term? The second term is now going to be what? 4, and the 4, that's the numerical common factor, numerical factor of the second term. It should be 4. 2 times 4 is 8, and we put the minus already. And 8 to the -2, and minus half. 8 to the -half, we have it already here. So 8, we don't need a. And the b, we do need a b. We need b. E to the 1. E to the 1. Once again, I'm using a yellow marker here. Okay. Do you see my yellow marker? B to the 1. I think I might be the only math teacher who is using a yellow marker. Okay. So once again, when I use a yellow marker, what does that mean? What that means is if you write it, it's not wrong. But generally, we don't write. Okay, that's what it means. That means you don't need to see, you don't need to write. Okay? Again, if you do write, it's not wrong though. That's what yellow means. But we prefer not to write. So therefore, I write that in yellow so that almost nobody can see. All right? So it's -4b. And then c. Now we have to look at c. C. Do we need c? We don't need c. There's no c, and there's no c here. So we don't need a c here. Now the last thing is d. Now we have d to -2, but we have d to -2 right here. So let me go back to red again. We have d to -2, d to so it looks like we don't need the d. So this is it. So this is it. By the way, if you write the final answer this way, 8 to the -half, if you write the final answer like this, that's acceptable, of course. Now, the 8 to the -half, if you write that as 1/8 to the half bar like this, am I going to accept that? Yes, I will accept that too. Or if you write the final expression as 1/square of a, am I going to accept that? Yeah, I'm going to accept this one too. So I'm just explaining the a here. So here we have 8 to the -half. If you write the answer this way, that's welcome. That's the best thing. That's the standard way of writing it. But instead of writing 8 to the -half, if you write 1/8 to the half power, like this, I will accept that. If you write 1/square of a, I will accept that too. And same thing for b and c, or like b to -2. If you write that as 1/d squared, I will accept that too. So I will be a little bit flexible. Is that clear? But the way we wrote down the answer over here, this is the most standard way of writing the answer. So therefore, I think this is how you should write the answer. This is the recommended form. All right? Any questions here? Do you have any questions? No? No questions. Easy? So is this very easy or is it very, very easy? Which one is it?
I would say very easy, because you just want to make sure you get the notations right. And you don't accidentally write something incorrectly.
Yes. And by the way, you know what? Instead of giving you a question like this, I could actually give you the original problem using radicals, like square roots and cube roots. If I give you square roots and cube roots, I think the best thing is for you to convert them to these fractional exponents. Usually that is the way to go, okay? But anyway, right now, let me just save this and clear this. What I like to do is I would like to now go back to the M0 test file, and now let's look at those problems over there. Let's see what we have there. So what we have is files here, and let's look at M0 test prep. M0 test prep, the number is 0700. This is one of the important files I mentioned at the beginning of this session. Okay, so we have this now, and so we have this. Okay, so now we have done example. Now, yesterday I did example 6, but right now, well, I did those examples to get ready for these problems on rational exponents. So we have now example 6, 7, 8, 9. Example 6, we did it yesterday. So you can look it up, or should I do that again? Oh, you know what? I cannot do all of them. So let's look at, how about example 7? Example 7 would be a good example. So let's look at example 7. Oops, what happened here? Oh, what happened here? Okay. Let me just put this on the bottom here. Okay, so example 7. Second. I'm trying to get my screen here, so let me share the screen. Screen is this screen. Okay, there we go. Now we are back. Back to section M0 test prep. Now let's look at the file here. Let's look at example 7. Okay, example 6, 7, 8, 9, very similar. Okay, now let's look at example 7. Example 7. Okay, so let's do it. Example 7. Example 7 here. Let's simplify this. Now, although it says simplify, many times we actually factor. That's the way to simplify. Okay, so now let's look at example 7. Example 7, we scan the whole entire expression. We have a times here, so this is one behaving like one term, and then minus another term. So it looks like we have two terms here, roughly. It's behaving like two terms. Okay, so now let's look at the first term here. If you look at the first term, what are the exponential forms? We have this and then times that. So the first exponential form, the base is 1 minus x. Okay, 1 minus x. Now we look at the second term, we also have 1 minus x here. Okay, so should we factor 1 minus x? Yes, we do. By the way, the numerical factors, we don't have it. It's only 1 and 1, so it's 1. So we can, we have no common numerical factor. And so now we look at the base of 1 minus x. So do we factor 1 minus x? Yes, we do, because we see 1 minus x in both terms. 1 minus x. 1 minus x? Yes. 1 minus x to what power? 1 minus x to what power is this? Or negative 1/3, because negative 1/3 is the lower of the two exponents. Whether it's negative or positive, you always factor 1 with a lower exponent. Okay, so that's that. So 1 minus x to negative 1/3. Now, the next one, we have 1 plus x, 1 plus x. So 1 plus x is also a common base. So 1 plus x, we have to factor. 1 plus x to the what exponent do we factor now? Negative 2/3. Everybody? You all follow me here? Then we have
Yes.
this big factor. Everybody? Entiende? Capiche?
Yes, capiche.
Okay, capiche. All right. So now, and then besides 1 minus x and 1 plus x, we don't have any other base, so that's it. And now we have to figure out this big factor. It looks like there will be a minus in front of it, in the middle here. Okay, let's see what we have. Okay, so now the first factor, we want to figure out what goes in here. Okay, so that will be, let's see, this guy, 1 minus x to negative 1/3. Well, we already have 1 minus x to negative 1/3 here, so we don't need 1 minus x here. So now the next one is 1 plus x. So 1 plus x to 1/3, well, we have 1 plus x to negative 2/3, yes. We do need 1 plus x. 1 plus x to the what power do we need here? 1 plus x to the what power do we need? Can you tell me? 1 plus x to the what power do we need?
1.
Yeah, in fact, we just need 1 plus x. So let me write a yellow here. It's we need 1 plus x to 1 first power. So 1 plus x to negative 2/3 times 1 plus x is 1 plus x to the 1/3 power. So we got it. You always check. Whenever you factor, you always check by multiplying. Okay? Again, when you factor, you don't try to factor again. That's not what you do. For any kind of factoring problem, you always check by multiplying. That's the way to go. Okay? Now, the second, and then we have a minus in the middle. Now the second term. Second term, let's see. Let's look at the factor with base 1 minus x. We have 1 minus x to negative 1/3, but here we have 1 minus x to 2/3. So it looks like we do need 1 minus x. 1 minus x to what power? 1 minus x to what power? 1 minus x to what power do we need?
1.
1 minus x to what power? 1. That's it. So 1 minus x to negative 1/3 power times 1 minus x is 1 minus x to 2/3 power. There we go. Just 1. And then now the next factor is 1 plus x. So 1 plus x to negative 2/3. So we don't need 1 plus x. If you multiply all that out, if you multiply all this and that right there, we do get this. So it looks like this is it. Now, it's not over yet. Now, for this here, we can simplify this. So 1 plus x minus 1, and the minus parenthesis 1 minus x. So it's 1 plus x minus 1 plus x. So this whole thing actually becomes 2x. So let's write it out. So the final answer is going to be this. Is going to be, let me write over here. This will be 2x, and then times 1 plus 1 minus x to the, what, negative 3rd power, negative 1/3. So negative 1/3. And then we have what? We have 1 plus x, 1 plus x, and then raised to the 1 plus x raised to what? Negative 2/3 power. And so this will now be the final answer. Negative 2/3 power. So negative 2/3. Kind of hard to see. Oops, it's a real mess here. Anyway, you get this, okay?
You
So
could
this
put
last
the negative powers in the denominator, right? That'd still be considered correct?
That's considered correct too, yes.
Okay.
So if you write the answer like this, if you write the answer like 2x, and then write over this here, and then what? 1 minus x to the 1/3 power, or 1/3 power like this, and then this right, and then times 1 plus x like this. They write 2/3 there. Yeah, if you write anything of this sort, that's okay. I'll accept that, sure. Now this is calculus. All of you are mathematical adults. Is that correct? Are all of you mathematical adults? Yes.
Yes.
If you're taking calculus 1, then I guess yes, all of you are mathematical adults. So you can, if you write it this way, yes, you can write. So those kind of things, different ways of writing, generally okay. All right. Make sure it's not wrong. And instead of that 1/3 power, if you want to cube root, that's okay too. I'll accept that too. Although there's no reason to write the cube root there, but I will accept. Okay, so that's that. Okay, so that's that. Now let me save this, and now let me clear this. How about this? How about, you know what? Let me quickly do this example 9 here. Example 9. Let's see. Example 9. This and then minus this here. So now let's see. What do we factor here? Well, we have 2x minus 1. Yeah, well, again, 2 terms here. 2x minus 1 to the half power. And the second term is 2x minus 1 to negative 3/2. So it looks like we have to factor negative 3/2. And the next thing we see is we see x here. But note that this x is really x to negative 1. So what do? We will factor that x to negative 1. X to negative 1. Again, if you want to write that as over x, that's okay too. So x to negative 1. And then x, that's it. And then there's nothing more. And then, so therefore, the factor is going to look like this. So let me just finish up here. This is going to be 2x minus 1. And then raised to what power? Raised to the what power would that be? We have 2x minus 1 to the negative 3/2, and we want 2x minus 1 to the half power. So it looks like we need what? We need 2. 2. There we go. And then minus, yeah, and then x to negative 1, yeah, we have x to negative 1 right here. So x is now done. So now minus, now get the second term. Now we have x here, but we have x to negative 1, but we want x. So it looks like we need x squared. And then 2x minus 1 to negative 3 half, so we have it already right here. So this is it. So it looks like this is it, but this is not it because this last factor right here, we can multiply this out and simplify. So if you just simplify this guy right here, this guy, you want to simplify this guy, what is that going to be? That will be 4x squared. Oh, minus 3x squared. So you know what? Let me let me save the one step here. I don't want to write this again. Okay, so I'm a little bit lazy now. So 4x squared minus x squared is actually 3x squared. And then if you multiply this out, you get minus 4x, and then plus 1. So this last factor right here, I want you to simplify this by multiplying all this, and then that's what you get right there. And then these two guys, you just copy those. There's nothing much there, so that's how you write the answer. The final answer will be this, all this, and then times, well, this last factor is same as this, so you write this guy right here. I just don't want to write the whole thing, I'm a little bit lazy here, so anyway. So that whole thing, and then times that up there. So that will be the final answer. Any questions here? Any question? No questions? Okay, then I think it is now our favorite time, and that is our break. Okay, let's have a break here. So a break, yes. What is our break? Okay, so let me save this, and then okay. So let me just clear this. Just clear this here. Okay, I'll just leave it there. All right, now let me just have a break. Time is now 9:40, so now let's have a break time. 10-minute break. And then what? 10-minute break, what is it? Continue at what? Continue at what time? 9:50. All right? Class will have a 10-minute break. We'll be back at 9:50. Anybody has any short, quick questions on this problem? Okay. I'll be back in 10 minutes. If you have any questions, you can ask me questions when you come back, okay?